All right, we're going to talk about the second part of functions in this presentation, which is function notation and evaluating functions. This also comes from section 2.1. So function notation is first and foremost notation that denotes an equation is a function. In an equation, we're going to replace the output or the y variable with our notation f of x, which is read f of x. F of x means the function evaluated at x. It does not mean f times x. Make sure that you pay very close attention to this fact right here. This is not multiplication. This is a notation. Parentheses have various meanings in mathematics. It can mean multiplication. It can also mean a point. It can mean an interval. And now we have another definition for parentheses, which is in function notation. So when we look at f of x, remember that this is equal to y. So when we look at this, numbers inside the parentheses are always the x values or the x coordinates. Numbers that are on the other side of the equal sign are always y values or y coordinates. So let's go ahead and look at an example. If we look at an equation, for instance, y equals 3x minus 5, what we can do is we can rewrite in function notation. All we do is we replace the y with f of x. Y equals 3x minus 5 is a function, and so we can write it in function notation. Now in the past, what we've done is we've always asked the question something along the lines of what is y when x equals 2? And so one of the benefits of function notation is we can shorten up this statement into find f of 2. This is the exact same thing. This is what is y when x equals 2? In the equation y equals 3x minus 5. Another benefit to function notation is that we can use different letters to represent different equations. For instance, I can have f of x equals 3x minus 5. I can also have something like g of x equals x squared minus 2. And we can go ahead and change the f to be any letter that we want. In equation notation, we have to be told what equation what equation is being referred to if we want to find a coordinate, or if we want to evaluate it. In function notation, we can have several different equations, and we can know exactly which equation to look at by its definition, whether it be an f, a g, an h, etc. Okay, so let's go ahead and start by looking at what we're going to do. So remember that when we look at functions, the inside number, this is the main thing you have to remember with functions. The inside number is always an x coordinate, and the outside number is always a y coordinate. So for instance, if I look at f of 0, 0 is an x coordinate. We want to know what is y when x is 0 in our table. So if we come over to our table, when x is 0, y is 2. So f of 0 is 2. Similarly, let's try one more. If we want f of 3, again, I want to know what is y when x is 3. So looking at our table, we're going to go to our x column. We're going to find where x is 3, and I want the corresponding y value. So f of 3 is equal to 5. Okay, now we can go the other direction. Now one of the things is when we go the other direction, we're always going to be told the following thing. Determine the values of x such that f of x is equal to 3. That means we are looking for x, so what are we going to be given? We're going to be given the y coordinate. So when we look at this, we have the whole f of x equals 3. Meaning I want to look in my column, my f of x column, and find 3. And I want to know what is x when f of x is equal to 3. We get x equals 1. Same idea, let's try one more. We want f of x equals 2, so I want to find where f of x equals 2. We're going to come to our f of x column, look for 2, and we get x is equal to 0. All right, the last thing that we're going to look at in our tables is something called determine the zeros. Determine the zeros, just to let you know, whenever you see this, we want to know when the function is equal to 0. So we're going to look for where f of x equals 0. So if we look at that, where are we going to look? We're looking in our f of x column. We get f of x is equal to 0 when x equals -2. All right, that takes care of our f of x function. So let's look at a couple more. If we look at g, first thing we have is evaluate the function. Remember again that numbers inside the parentheses, these are our x's. So what we want is g of 1. That means I want to know what is g of x when x equals 1. So if we look at our table, we have x equals 1 right here. We come across and we get g of x equals -3. So g of 1 equals -3. Same thing with g of -2. I'm going to start by looking for where x is -2. We come across and we get 0. So when x is -2, g of x equals 0. So g of -2 equals 0. All right, for the next question, we have determine the values of x such that g of x equals -3. So where is it equal to -3? Remember, we want to determine the values of x. That means that my -3, I'm looking for it in my g of x column. Well, the first one that we have is here. G of x is equal to -3 when x equals -3. That's not the only one. We do want to find all values of x. If we come down further in our table, we also have a -3 here. So it also happens when x equals 1. So we get two solutions. We get x equals -3 and 1. All right, let's go ahead and look at g of x equals 1. Again, I want to find where 1 is in our g of x column. We have it right here. We get x equals -1. All right, determine the zeros. Remember that determine the zeros means where is this thing equal to 0? So we're looking for 0 in our g of x column. So what do we get? We get x equals, we have a 0 here, x equals -2. We also have a 0 here. So we're going to have x equals 0. All right, last function that we're going to look at for tables. We have h of x. So for the first part, let's go ahead and find where x is -3. And we want to know what is the h of x equal to. So if we come to -3, we have h of x equals 4. Similarly, for h of 5, remember 5 is an x value. So we're going to have 5. We get h of 5 is also 4. Okay, let's go the other direction now. We want to determine the values of x such that h of x is equal to 4. So what are my values of x? Well, it's actually going to be all of them. So we get x equals -5, -3, -1, 1, 3, and 5. Okay, is this thing ever equal to 2? We want h of x is equal to 2, so we're looking for 2 in the right column. It never equals 2, and so what do we say? We say no solution. We want to determine the zeros of the function. Remember, that means our function is equal to 0. Is this ever equal to 0? No. So this is also no solution. All right, so that takes care of our tables. So now let's go ahead and look at some graphs. Okay, so again, same idea. Remember that when we look at graphs, we have a lot of points here, and we have every single point has an x-coordinate and a y-coordinate. So just remember that the inside number is an x, and the outside numbers are the y's. So when we look at f of 0, I want to know which point has an x-coordinate of 0, and I want to know what is the y-coordinate of that point. So remember, when x is 0, we do not move left or right. We're just going to go up or down. So if we look at our graph, here is x equals 0. We want to move along this line and figure out where the graph crosses. It crosses right here. And so we get y equals 1. F of 0 equals 1. Okay, f of 3. In order to find this, we're going to come over to where x is equal to 3. And we want to go along our graph to figure out where it crosses our graph. We're up here. This point right here has an x-coordinate of 3. We want to know our y-coordinate. Our y-coordinate is 5. So f of 3 equals 5. Okay, so again, we still have the same question going the other direction. We want to determine the values of x such that f of x is equal to 3. This is my y-coordinate now. So if we look for where y is 3, that's going to be going up and down on my y-axis. We're going to come across, and it looks like it happens right around here. This is at about 1.5. All right, what about f of x equals 2? Same thing, we want to go ahead and look at where y is 2. And we want to find our graph where it crosses, and it looks like it crosses right here. What is x? What is the x-coordinate of this point? It is 1. So we get x equals 1. Okay, that's determined the x values. The next thing we have is determine the zeros of the function. So remember again, this means f of x equals 0. This means y equals 0. So we are looking at going left or right. We are not looking at going up and down from our x-axis. So zeros, this is also another way to say what is the x-intercept. So if we go ahead and look for the x-intercept, our x-intercept is right here. What is the x-coordinate of this? This is x equals -2. Another thing that we're going to look at as we progress through this class is we're going to also talk about minimums and maximums. So notice here it says what point is the minimum and what point is the maximum. When you're being asked to find a point, then you want to write it in point notation. Another thing that can be asked is what value is the minimum or what value is the maximum. In that case, you are only wanting to include the y-coordinate. But for this one, we want to know what point is the minimum. So our minimum, we are looking for our lowest point on the graph. Lowest point on the graph occurs here. We want both coordinates. So how far to the left did we go? We went 4 to the left, and we went 3 down. So our minimum point is -4, -3. Similarly for our max, where is our maximum point? Our maximum point is right here. We want to know what are the coordinates. So my x, to get there, we're going to go 3 to the right and 5 up. So this is going to be 3, 5. All right, let's look at a couple more. If we look at graph 2, I want to know what is g of 1. If we go ahead and find 1 on our graph, this is an x coordinate, so that means I want to go 1 to the right. And if we go down, we end up at negative 2.5. All right, if we look at g of negative 2, again, negative 2 is an x coordinate, so we're going to go 2 to the left. And how far up do we go? It looks like we go up 5. So this is going to be negative 2. G of negative 2 equals 5. All right, g of x equals negative 3. Remember, we want to determine the x values, so that means that negative 3 is a y coordinate. If we look for negative 3 on our graph, we have an x coordinate of 2, so that means x equals negative 2. All right, for g of x equals 4, we're looking for 4 on our y-axis. If we come across, I'm going to say this is going to be a little less than negative 2. So I'm going to go ahead and say, let's go with negative 1.7. It's not halfway, but it's not all the way to negative 2. And so there is going to be a little bit of leeway on these if you have to estimate. If we go the other direction, we also have that it is equal to 4. Not only on this side, but it's also equal to 4 on this side. Same thing, it's not all the way to the tick mark, it's a little less. So this looks like, I'm going to say 5.8. And again, this is an estimate, so there is going to be a bit of leeway on this. All right, that takes care of our g of x. Now let's go ahead and determine the zeros. So again, remember we are looking for x-intercepts. We want to know, where is this thing equal to 0? Where is it crossing the x-axis? First one we have is right here. Looks to be about halfway between 0 and negative 1. So I'm going to go ahead and say negative 0.5. But we also have an x-coordinate over here. And I'm going to go ahead and say about 4.5. All right, we also have what point is the minimum and what point is the maximum. So minimum, what is our lowest point on the graph? The coordinates are there. It is at 2, negative 3. Maximum, well, if you note, this thing does have arrows that go up forever. And so it has no maximum. All right, let's look at a couple more graphs. We have graph 3. So let's see what we can do here. We have f of 1. Remember, this means x is 1. So we are looking for where x is 1 along our x-axis. Our y-coordinate, we go 2 up, so f of 1 is equal to 2. What about f of negative 1? Means my x-coordinate is negative 1. We go up, it looks like it crosses at about 3. All right, let's go the other direction now. We have f of x equals 4. That's my y-coordinate. I come across, and to me it looks like it crosses at negative 5. That we have a point negative 5, positive 4. So we get x equals negative 5. For f of x equals negative 2, we're going to go 2 down on our y-axis. Notice the graph never actually comes down this way, so what do we say? We say no solution. All right, determine the zeros. So determine the zeros. Remember, this is where it crosses the x-axis, and we want to find the x-coordinate. So if we look along our x-axis, we have a 0 right here. We do have when x equals 3, y equals 0. And so that is going to be our 0. We get x equals 3. Minimum. Our lowest point on this graph is at 3, 0. And what about maximum? This graph goes forever up, and so it has no maximum. All right, last example for our graphs. Graph number 4. First thing we want to do is find f of 2. We're going to go 2, this is an x-coordinate, so we're going to go 2 to the right. We're going to go up until we intersect our graph. It intersects right here. This is y equals 2. All right, f of x equals negative 1. Same thing. We want to go 1 to the left. We're going to go down until we intersect the graph. The y-coordinate here is negative 4. All right, going the other direction. We have determined the values of x such that f of x equals 4. That means I want to go up 4. We're going to go across until we intersect our graph. This happens at x equals 3. F of x equals negative 2. We're going to go down 2. And it crosses on the y-axis, so what is x at this point? This is x equals 0. Determine the zeros. Remember that means our y-coordinate is 0. So we are looking for x-intercepts. So where does it cross our x-axis? Crosses right here. And at this point, we have our x-coordinate is x equals 1. Okay, minimum and maximum. This actually has no minimum. This arrow indicates that this graph keeps going down. For maximum, we have an arrow at this end that goes forever up. And so we have no max either. All right, that takes care of our graphs. The last thing that we're going to look at is equations. So again, the main thing to keep in mind is just remember where you're going to be plugging in. So for instance, if we have the function k of x equals 1/4 x minus 2, the first thing we want to do is evaluate k of 8. 8 is inside the parentheses, meaning it is an x coordinate. So to evaluate this, we're going to replace x with 8. To go ahead and multiply this, I'm going to go ahead and put 8 over 1. I can go ahead and cancel. 4 and 8 are both divisible by 4. We get 2 and 1. And if we go ahead and simplify that, we get 2 minus 2 is 0. So k of 8 equals 0. Make sure that you do not put k of x equals 0, because then basically you have a new equation. We want to make sure that we emphasize that this is the function evaluated when x equals 8. Okay, so the next thing we want to do is we want to determine the values of x such that k of x equals 1. What that means is I want to replace the whole k of x with 1. So what we get is 1 equals 1/4 x minus 2. And I want to go ahead and solve this equation. So we get plus 2 to both sides. And then to finish this off, to get rid of 1/4, remember to get rid of a fraction, we can multiply by the reciprocal. I can multiply both sides by 4. On the right, it cancels out, leaving me with x. And on the left, we get 4 times 3 is 12. And so what values of x is k of x equal to 1? X equals 12. All right, let's try one more. Again, same thing. Remember that k of x equals -3. We are looking for x. So I'm going to plug in -3 for the entire k of x. So we get -3 equals 1/4 x minus 2. To go ahead and solve this, we're going to add 2 to both sides. We get -1 equals 1/4 x. Again, to get rid of the fraction, I'm going to multiply by 4. I'm going to multiply by the reciprocal. On the right side, my 4 and my 1/4 cancel, leaving me with just x. And on the left, we get 4 times -1 is -4. Okay, last thing we want to do is determine the zeros. Remember that the zeros means k of x equals 0. So again, just like on the last two, we're going to replace k of x, the entire k of x, with 0. And we solve. So we're going to add 2 to both sides. We get 2 equals 1/4 x. We can multiply by 4 again. On the right, my 4 and my 1/4 cancel, leaving me with just x. And we get 4 times 2 is 8. All right, that takes care of our function k of x. Let's keep going and see what we can do. All right, the next function we have is g of x equals 5. Now be careful on this one, don't overthink it. If we plug in 17 for x, do I have any x's to plug it into? The answer is no, so what do we have? Well, g of 17 is equal to 5. And we're done. Okay, for the other ones, determine the values of x such that g of x is equal to 5. So for the first one, g of x equals 5, what are the values of x that I can plug in? Well, no matter what, it's going to equal 5. We can't replace any x's with anything. And so notice the whole thing's equal to 5 no matter what you plug in for x. So what does that mean? That means our solution is all real numbers. Or if you want, you can put it in interval notation. Negative infinity to infinity. For g of x equals 0, well, we have g of x equals 5. It's always 5. Is it ever going to be anything other than 5? The answer is no. So what we have here this is no solution. All right, so that takes care of kind of our tricky example that we can't do a lot with. So let's go ahead and look at one final example. Let's go ahead and look at p of x equals the square root of x minus 1. Now we will explore this later this semester. You won't see this in any of your homework problems right now, but we will see it later on, so I just want to kind of mix it up a little bit and show something a little bit different than linear equations. So the first thing we have is we have p of 5. Remember that means since my 5 is inside my parentheses, my x is a 5. So I want to replace x with 5 in my function. We get 5 minus 1. If we go ahead and simplify this, 5 minus 1 is 4. And the square root of 4 is 2. So p of 5 equals 2. Okay, let's go the other direction now. We want to determine the values of x such that p of x is equal to 3. So remember, for this we're going to replace the whole p of x with 3. We get 3 equals the square root of x minus 1. Hopefully you guys remember you cannot solve for a variable if it is inside the square root. So we want to get rid of the square root to start off with. How do we get rid of a square root? We're going to square it. And remember that our rule with equations is whatever you do to one side, you have to do to the other. So I want to square both sides of my equation. If we do this, we get 3 squared is 9. On the right, my square and my square root cancel, leaving me with x minus 1. And to solve for x, we add 1 to both sides. So we get 10 equals x. All right, last one, determine the zeros. Remember, this means p of x equals 0. So I'm going to go ahead and plug in 0 for p of x, the whole p of x. We get 0 equals the square root of x minus 1. And again, we solve. We can't solve if x is inside the square root. So the first thing I'm going to do is square both sides. 0 squared is 0. On the right, my square root and my square cancel, leaving me with x minus 1. And to solve this, we're going to add 1 to both sides. We get 1 equals x. All right, so that takes care of evaluating functions and function notation. Again, I don't have any extra videos for this from my 114 class, so if you have questions, please feel free to contact me. All right, that should be it for this week. Again, take your time on these homework assignments. Make sure that you understand the concepts. If you need to rewatch the videos, please rewatch the videos.